Here for lesson 5G, we have problems with more than one triangle. So this one isn't drawn for you, so I drew it for you. So please draw that triangle. So I'll give you a moment to do so, and then I'm going to show you how we label it. Here we go. Alright, so we got two planes, and they're leaving the airport on different runways. So plane A travels. Now the reason I've got it this way is because here's our Cartesian plane. Now, whenever we're talking about, this is directional language. Whenever it's directional language, we start at the direction that's first, and we go towards the direction that's next. So the first one says, plane A is starting going south, and then he's going 40 degrees towards the west. So that means this little piece in here is 40 degrees. Okay, and that means this is plane A. And then it says, plane C travels south 60 degrees towards east. So this part here is 60 degrees. So the entire angle, both of them together, which we're going to add together, is 100 degrees. That's why they told them both of us, so that we can add them together. So we got plane A and plane B. Now it says plane C travels, or sorry, I guess plane A and plane C, pardon me, not B. Plane C. Alright. So it says at an average speed of 280 per hour. So this guy's going 280 per hour, and plane A is going 320 per hour. Now that means 320 kilometers per hour. Now what we've got to do is it wants to know how far apart are they after 2 hours. So we want to know 2 hours. They've gone this many kilometers after 1 hour. What are we going to do to those numbers? We have to double them. Yeah, we got to multiply them by 2. So 280 we're going to times by 2, and that's going to become the length of this line right here. That's the length of that line. So we're going to get 560. And on the left-hand side, plane A for that line there, we're going to take 320 and double it. So 320 is actually going to become 640. Okay, so that's plane A and plane B. Now we want to know how far apart are they after 2 hours. So plane A will be in the air over here, plane C is in the air over here, but how far apart are they? Okay? So that's our diagram. We need to use the cosine law. So we're going to say x equals the root of 640 squared plus 560 squared minus 2 times both numbers, 2 times 640 times 560 times cos of our angle. How big is our angle? 100. Excellent. Just going to move that sucker over. Cos of 100. Okay? You don't need space there. I don't know why I put a space there. If you put it under the root sign, it's going to solve it for you all in one big shot. So everybody type it in. And this is how far apart they are after 2 hours. So what would you get for that one?
921.
Good. So we got 920.7, and we want the nearest whole number, so they are 921 kilometers apart. Okay, so that's how far apart the planes are. All right, last 3 examples of our trigonometry life here. Okay. Actually, let's just go back to this question for a moment. In the multiple choice, if this was a multiple choice question, what would be a good distractor answer?
920.
Okay, 920. What would be another good distractor answer? What if they forgot to double the numbers? If they forgot to double the numbers, they would have got a very different answer. Guess who did that the first time? Yeah, she did. And what she got the very first time was 460 kilometers apart. So really, if we double that, should we pretty much get this? Yeah, we get exactly that. So that could be another strategy. Figure out with the real numbers, and then they're 2 hours away, just double the distance. Okay, that would work in this case. But again, another distractor answer would be 460. Okay? All right, this one here. Now, it's not drawn very well in your diagram, so I'd like you to draw the diagram the way I have it drawn, please. So what we've got is two security cameras. We've got security camera A, I'm going to put an A up here, and we got security camera B. And they need to be adjusted in our museum here because they're going to be focusing on the top of a display. Now this is the display that I'm shading in blue. That's the display case. And that's what they're focusing on. Now it says the walls are 21 meters apart. This is, I changed it in mine, but yours says 12. It was a typo. It should be 21, not 12. So please change that number in yours. Okay, it should be 21 meters apart, not 12. Okay, so let's take a look at what it's actually asking us. And we're going to label everything. So it says the cameras are mounted 6 meters above the floor. Well, if this is our floor, we know that all of that is 6 meters. From the bottom to the top of our cameras, on both sides, is going to be 6 meters. Okay? Then it tells us the fossils are displayed in cases, and the case is 1.5 meters above the floor. Well, that's telling us that this height right here is 1.5 meters. So we need to know how far would this be then? 4.5, because it has to make a 6. So that's going to be 4.5, and it's going to be the same on the left-hand side, because this is still 1.5. The display case is 1.5 off the ground, and which makes this 4.5. Okay, it's total for our 6. All right, so here's the top of our display case. So that's why I've drawn this line here, because this line is our horizontal line that we are going to create from our triangles. So now what it wants to know is it wants to know the angles of depression from the cameras. Well, what that wants is it wants this angle and it wants this angle. So we have to find both those angles. So that's what's going on. Well, we first of all need to find a couple numbers first. So, is it safe to say that if I were to add this angle of depression and this, it would make a 90-degree angle? Is that safe to say? Yeah, because it's connected to a wall, right? The camera's up on the wall. So the walls are going to be 90 degrees. So same as this angle, those are going to add to 90 degrees. That's a 90 degree there. Okay, when you add both together. That's going to help us out. So, it also tells us that the distance from the camera on the left to the center of the display is 14.8. So let's watch the way that I'm going to follow my line here. Camera A to the middle of the display. The diagonal line is 14.8. Okay, so we know a little bit about that triangle. So now, if I know that this whole angle up here gives me 90, and I need to find the angle of depression, I can find this part of the angle first, and then just subtract from 90. So, I have, now I'm going to label, I'm just going to redraw my triangle over here so you can see what I'm dealing with. I've got 14.8, I've got 4.5, and I want my angle. So, if I were to label this guy, who is my 14.8? Hypotenuse, good. And who would be the 4.5? Adjacent side, good. Well, that's going to give us the cos, right? We could also use sine law in here if we wanted to, because we do have an opposite pair. We've got 90 across from that guy, but then we got 4.5 across from this bottom angle. Okay, we'd have to find that one first, then subtract from 90 to find that one. But that's using sine law. SOHCAHTOA works much better in this case. So we're going to use cos, because we have A and H. So we're going to say cos of theta is 4.5 over 14.8. Now, in order to find angle, we got to hit the second button. So we're going to go second cos, and then we're going to divide the numbers. So second cos divide. What do we get for an angle? Second cos, 4.5 divided by 14.8. 72 degrees. Did everybody get that? Yeah? Good. So, angle theta is 72 degrees. Well, that's not the angle we wanted. We want this little itty-bitty angle up here, the angle of depression. So, we know they both add to 90. So, we're going to take 90 now, and we're going to subtract the 72 degrees. That's going to tell us our angle of depression up here. So, how big is that angle of depression? 18 degrees. Excellent. So I know one of my angles of depression, 18 degrees. I'm just throwing it up on top there. Now we got to go over to the other guy over here and do the exact same thing. Now, I need to know this bottom number. They didn't give me the diagonal number, but I can find the bottom number. How do I know? Well, let's take a look. They tell us that from one end to the other end, like the walls themselves, are 21 meters apart. Well, I can find out this little piece by going 21 minus this piece. Now, am I able to find that piece? We sure can. We can use SOHCAHTOA or Pythagorean theorem. I can go 14.8 squared, subtract 4.5 squared, and I'm going to get this squiggle line on the left. We can find that guy. So how big is this squiggly line I'm coloring in green? If you use your Pythagorean theorem. 14.8 squared minus 4.5 squared, and square root the answer. So how big is it? 14.1. Perfect. Thank you. So we get 14.1 for this far. That's that green squiggle line. Well, it tells us that this yellow line, the distance between the walls, is 21. Well, I can take 21 and subtract 14.1, and that's going to give me this bottom one. So, how big is that bottom over there? 6.9. Thank you. All right. Now, I'm going to erase a little bit of stuff here because I've got a lot of information going on here. So, I'm going to redraw the triangle on the left. I've got 4.5 and I have 6.9 on the bottom. I need angle theta. So we now are going to label. I've got opposite and adjacent. I need to use what? Tan. So second tan theta equals 6.9 divided by 4.5. So second tan, divide the digits. Second tan, 6.9 divided by 4.5. Angle theta. How big is it this time? I hear lots of whispering. 57 degrees. Good. So, we know the inside part's 57. We want this outside part. So we're going to go back to 90 and subtract 57. So 90 degrees, subtract 57 degrees is 33 degrees. Good. So there's our 33 degrees. You will not see a question like this without a diagram being drawn for you. You would be expected, though, to label everything, okay? You could put an SE beside this question. This is a standard of excellence. You may only ever see one like that again. All right, let's take the next one. Now, the next one doesn't look as tricky as it is. I blew the diagram up because it's hard to see on the page. Now, I'm just going to redraw these triangles, unless you can see them. Can you see this number here is 42? Right there? And then right here, I'm just going to highlight this triangle right here, that little skinny one. Do you see that skinny one I'm doing? So we got a long, skinny triangle. You guys see that one right there? Okay. This is 5 degrees down there. 5 degrees. This is 40 degrees right there. Well, am I able to find this degree? Yeah. We're going to go 180 minus 45. We're going to get 135. So this guy is 135 degrees right in there. Now we need that because we're going to use the 180 rule. If we take a look, we've got a straight line right here. And if this guy right here underneath is 100 and how big? 35. 135 degrees. This part here plus this part has to add to 180. So we're going to have 45 degrees here. Okay, do you see where I got the 45? It's kind of hard to see on that diagram. So this is 135, that's 40, that's 5, and then it's going to continue up. This part's 65 degrees. Okay, that's this. Or sorry, not 65, 45. My bad. 45 degrees. Okay, does that make sense of what's going on there? And then this line is 42 meters. And that's this green line here. Okay, that's what we've got going on. And we want to find the height of the totem pole. That's what we're actually asked to find. So we have opposite pairs. So if this is 90, everybody take a look. This is 90 right here. That means this part's 90. Well, if that part's 90 and the teeny piece is 5, how big is the rest of it? 85. So that angle right here is 85 degrees. Okay, right here, this angle, that's 85 degrees. And now we have our opposite rule. So, if we know two angles of a triangle, we can find the third. So I know two angles. I know these two bottom ones, 45 and 85. I can find this tall one right here. Okay, because it's 180 minus. How big is that angle up there? 50, good. So now we have to use our opposites rules. So let's find our opposite pairs. So I have an opposite pair here, 50 and 42, and I need to find H. Who's his opposite? 45. So the way we're going to draw our sine law is like this. We're going to have 42 over sine 50 equals x over sine 45. Now we're going to cross multiply this way and divide by sine 50. That will give us x. And we want it to the nearest one decimal place, nearest tenth. So what do we get when we do our nearest tenth? Yep, 38.8 meters. Okay, so the real totem pole in real life is 38.8 meters long. Now the next one is a diagram that's going to kind of melt your noodle. So I'm just going to show it to you. It's kind of interesting, this diagram. On the next question. Okay, so if we look at this diagram, I kind of blew it up right here. It's showing us the 90 degrees right here. So I know this one right here is 90 degrees, right there. And I'm going to start to label everything from this diagram onto the bottom one, okay? So I've got 60 there, I've got 50 degrees, 60 degrees, and 76 degrees is right there. And that's all we know so far. Okay? We want to determine the height of the cliff. So the height of the cliff is right here, H. That's what we're trying to figure out. And we've got Brendan, who's standing right here, and Diana, who's standing right here. They're both going to walk to the base of the cliff, and then they're going to go up. But we need to know how tall the cliff is. So, we've got a triangle at the bottom, and all three angles are going to add up to 180. So, if they have to add up to 180, this guy's got to be 70 degrees. Now, why do I need to know that? Because remember, whenever we have a joined triangle, we need to solve the side that they share together. Well, the side that they share together is this side right there. So that's the side we have to calculate and find in order to find our H. Okay? So, we're going to take a look. We have an opposite pair here, and then this guy would be our X, and his opposite pair is 50. So I have opposite pairs to use my sine law. So I'm going to have X over sine 50 equals 60 over sine 70. And now we are going to cross multiply this way and divide by sine 70. And that's going to give us x, which is going to help us find the height of the cliff. So, x is 48.9 you should get. You get 48.9, everybody check? Get 48.9. So 60 times sine 50, enter, divide by sine 70. 48.049. So we do get 48.9. So that's this one. I'm just going to redraw the triangle with the H. So the triangle with the height that we're looking for H. We just found the bottom number, 48.9. Let me redraw. That didn't work out very well. So 48.9, we're finding H, and the angle they give us is 76 degrees. Now we have to label everything again. So, circle the angle, I have my adjacent and opposite, I'm going to use tan. So we're going to have tan of our angle 76 equals height, which is x, over 48.9. Now, are we multiplying or are we dividing? We are multiplying because the variable's on top. So we take the number off the bottom and we times it to tan 76. So 48.9 times tan 76. That's going to give us to the nearest meter. How tall is the cliff? Yes, 196.1, which just rounds to 196. So 196 meters is the height of the cliff. This concludes our trigonometry unit.